Good day everyone, my name is Chang Ming and my partner's name is Khor Ji Jun. We are undergraduate students that are currently undergoes our study in University Technology Petronas. In this video, we will be presenting about the RSA crypto system. Let's start off by giving a brief introduction on what is RSA. So RSA is known as one of the oldest crypto systems and is widely used for secure data transmission. Furthermore, RSA is an asymmetric or public key crypto system, which means the keys that are used to encrypt and decrypt a message are different, unlike the symmetric crypto system that use the same key. The name RSA came from the surname of Ron Rivers, Eddie Sherman, and Leonard Adamo, the group of people that came up with this algorithm. In this video, we will be using a simple mathematical example to explain the working principle of RSA. Let us start with RSA encryption process. Let's say an encryption pair of numbers 5 and 14 are given, which act like a pair of locks that is used to lock up the original message. In our case, will be the plaintext letter B. So, in order to obtain the encrypted message, first we need to convert letter B to the number 2. Since in this example, we will be dealing with numbers and numerically b is equal to 2. Next step is to raise the plaintext to the power of e and then modulus of n. For that, we get 2 power 5 bracket mod 14. After that, we need to solve the equation to obtain the encrypted message. So to do so, first we calculate what is 2 power 5 and we get the number 32. 32 is then used to mod with 14 to get the remainder. Finally, after calculating the mod 14 of 32, we get the remainder of 4, which is the encrypted message or ciphertext of our original message B. So, and alphabetically 4 is equal to D. So, D is the encrypted message that we obtain after going through the process. So this is how the encryption process works. Next, I'll be talking about the decryption process. Decryption process is basically the reverse of encryption process. Let's say a decryption pair of number 11 and 14 are given, which act like a pair of keys that is used to unlock the encrypted message, which is the letter D that we had obtained previously. So, to get back the plaintext, what we'll need to do are, first, same as before, we need to convert the letter D to the number 4 since we'll be dealing with numbers. Next steps, raise the plaintext to the power of E and then modulus n. For that, we get 11 power 4 bracket mod 14. After that, we just need to solve the equations to obtain back the original message. So to do so, first we calculate the 11 power of 14 and we get 4,194,304. The number is then used to mod with 14 to get the remainder. Finally, after calculating, the remainder number 2 is obtained, the equivalent to the letter B, which is our original message. So this is the end of the encryption process. In the next slide, my partner will be going through on how the key of the decryption process are generated.
Hi, I'm Khor Ji Jun, and I'll be taking over my partner Chang Ming in explaining the key generation process to generate the encryption and decryption key for the RSA. So, in total, there are 5 steps for the key generation process. Step number 1, we are to choose 2 prime numbers for P and Q. In this case, P will be 2 and Q will be 7. These numbers are generally not publicized. Step 2, we will need to calculate n, where n is the product of P and Q. n will then become the modulus in encryption and the decryption key. In this case, n will be 14. Step 3, we will have to work out phi n, where phi n is the product of p minus 1 and q minus 1. In this step, first we will need to list out all the values of 1 minus n. In this case, 1 to n. In this case, it is 1 to 14. After that, from this list, we will be removing all numbers that is the common factor with n. Remaining numbers can be called co-prime with 14. In this case, the numbers 1, 3, 5, 9, 11, and 13 are the leftover numbers. The total number of remaining numbers should be the same as the value of 5n. Next, step 4, we have to choose an e value. There are two conditions that we have to follow in order to choose our e value, which are, first, e has to be in the range such that e is smaller than phi n but bigger than 1. In this case, e has to be in the range of 1 to 6. Second, e value will have to be a co-prime with n and phi n, which means it does not share common factors with 6 and 14 in our case. Thus, only the value of 5 is remaining, and e will equals to 5. Encryption key of 5 and 14 will be handed to everyone for the RSA encryption process. Step 5 and the final step is to choose the d value. There's only one condition to choose the d value, such that you have to choose d such that d times e mod phi n will be equals to 1. In our case, it will be 5d mod 6 equals to 1. The numbers will have to be a fit in d such that it is multiple of 5, which will give the modulus number of 1. In our case, d will be 11, since 5 times d equals 55, and d equals 11. You might be wondering why 25 could not be chosen. That is because the multiple of 25, d will be 5, which will be the same value as the e value from the last step. So the encryption key and decryption key cannot have the same value, so 5 will be omitted and 11 will be chosen. Thus, 11 and 14 will be the decryption key. That is all for our presentation. We thank you for your attention. We hope that our explanation has been more insightful for the RSA process.